So this is totally my fault. Normally, when we're in class, I do this lesson in 2 days, and I just totally messed this up because we're doing distance learning, and it's my mistake. So I didn't mention the two rates, and this is a really common theme on the AP questions, is they'll have basically a rate in and a rate out. And so I do want to just mention a few things, just kind of add these onto your notes, place them somewhere. And so basically what we want to kind of think is that our total rate would be equal to the rate in minus the rate out. And sometimes these are different rates. And so what we want to kind of think about is that if we have one rate, then it's nice and easy. We could have the integral from a to b of the rate of time dt is equal to the amount at b minus the amount at a. And a lot of times what'll happen on the AP exam is they'll give you some starting amount. They'll say like, at time 0 or whatever, there's whatever, however much stuff. So, and then they'll say like, write a formula for at any time. And so what, we can kind of almost rewrite this formula for is a of b equals a of 0, like our starting amount, plus the integral from 0 to b of the rate of t dt. And that b can change to anything. You can make it a time. So like, then it's a general formula, like at any time t. You'd make it like 6. If it's like, they ask you for 6, then it would be at time 6, right? Or we can leave this as b, and we could also even leave this as a, because they don't always give you 0. They might say like starting at, 4 or starting at 5, time 5. But basically, this is the same formula, but we just added a of a over, like the amount of a over, and put it in front of the integral. And we just switch the sides. But those are the exact same formula. That's with one rate. Now, when we have two rates, it gets a little bit more tricky, not too bad. But with two rates, essentially what happens is that now we want to do the integral from a to b of the rate in minus the integral from a to b of the rate out. And that kind of makes sense because, if you're basically, say you have a bathtub and you turn the water on in the bathtub, but it's slowly leaking out, right? It's not going to add on only by the amount of water that you're adding, but you're going to have to also subtract the small amount that leaks out. So we do the integral of the rate in minus the integral of the rate out, and that's going to give us the amount of water in the bathtub at B minus the amount of water in the bathtub at A. And so again, we can kind of change this formula to say that, the amount of water at any time t or at, time b is equal to the, we're going to add the a amount, the starting amount over. So a of a, this is kind of like, whatever they give you, like the given or the starting amount. And then plus the integral from a to b of our rate in, and then minus the integral from a to b of our rate out. And so again, those are the same formula. You can use whichever one you like, but a lot of times it can be a little bit faster to use that second formula. Again, same thing here, like this a of a, that was whatever our given amount was, or the starting value that they give you. And so I will do this question with us, this first question. I'm going to do it with you guys. And I told you that you get extra credit for doing more than 2 of these. I don't want you to pick this as one of the 2 that you choose, but instead you can. I will give you extra credit for turning this in. So basically you just watch the video and you get free extra credit for just following along. And this is a very, very typical AP response question. So for this topic of like this rate in, rate out. So they say the tide removes sand from Sandy Point Beach at this rate. So this is kind of like our rate out. And then a pumping station adds sand to the beach. So this would be our rate in. And so they say both R of t and S of t have units of cubic yards per hour, or like yards cubed per hour. And we're going from time 0 to time 6. And that's in hours, right? Because they said in hours. At time 0, the beach contains 2,500 cubic yards of sand. That's really, really important. right? So that kind of amount of sand, maybe call it just A of 0, is 2,500. That's important to make sure we know for that formula that we're going to use. Now, it's also important on the AP questions to make sure we read exactly what they ask. A lot of students will jump straight to this formula, and they'll get a question wrong because they didn't read what it asks. So question A doesn't say how much sand is in Sandy Beach. It says only how much sand just was removed. So that word remove is very, very key. So only how much sand is removed from the beach. So we're going to put A, just the amount removed is going to be just the integral of the rate out. So this is only going to be the rate out. So 0 to 6 of, we'll use R of t because that's what they gave us, dt equals. Now, you can, if you really want to, you can write 2 plus 5 sine of 4 pi t over 25 dt, but this line is actually optional. Okay, whereas this line is more necessary. Really, the key is you need one of these. So you don't necessarily need to write them both out. The AP graders are going to be okay if you never write that, because they know that you know that R of t is the same as 2 plus 5 sine of 4 pi t over 25. They'd also be okay if you only wrote the right side. If you want to write both, that's great too. Now we're going to type that all into our calculator. So in our calculator, we'll type that out, and the answer that you will get is 31.815. And then we should get, we need to add our units, right? It says indicate units. And so these were in yards per hour. We take the integral, we chop off the per time, so it would be yards cubed, right? It was yards cubed per hour. Right, and on the AP test, just so we know we're grading these, you would have gotten 1 point for the integral, and then 1 point for the answer, but the answer needed to have units. If you don't have the correct units, you don't get that point. Okay, for part B, then they say write an expression for y of t for the total number of cubic yards at any time t. So we'd say y of t, that's the amount, that's like the amount at any time, would be equal to y of 0, our starting amount, plus the integral from 0 to 6 of the rate in, which we called s of t, minus the integral from 0 to 6 of the rate out, which we called r of t dt. And so basically this is this formula right here. That's the formula we're using. Okay, so the amount at any time, and they called it y, is equal to the amount at 0 plus the integral from 0 to 6 of the rate in minus the rate out, right? That's the rate in. That's our rate out. And this is our a of 0, and this is our a of t. So that's kind of where we got all that stuff from. So this was worth 3 points actually, just for basically knowing the formula and applying it. So you got 1 point for having the correct integrals. So basically the s of t and the r of t, like s of t minus r of t. You got 1 point for having the correct limits, like from 0 to 6. And you got 1 point for putting it all together. All right, part C, find the rate at which the total amount of sand on the beach is changing at time 4. So the rate that the total amount of sand is changing at times 4. So basically the rate in and the rate out, basically add up to that total rate. So our total rate in this case would be the rate in, which is s of t, minus the rate out, which is r of t. You can write it like that with total rate, or if you want to use y, technically the answer key might say y prime of t equals s of t minus r of t. But I'm okay with you just writing, total rate in the AP grade order, so I'll give you credit for that too. And so then our total rate at time 4 would be s of 4 minus r of 4. You're just going to plug those into your calculator. you're going to do 2 plus 5 sine of 4 pi over t at time 4, and 15t over 1 plus 3t at time 4. Then you're going to subtract s of t minus, or s of 4 minus r of 4. So when you do that, you should get negative 1.908. And our units would be the same units, yards cubed per hour, the same units as what S and R's units were. Right. And this last one is from last chapter. And whenever we're given an interval and we're told minimum or maximum, that's the absolute maximum or the absolute minimum. So we want to kind of remember that. So this says for time 0 to 6, at what time is the sand a minimum, and then what is the minimum? So at what time and then what is the minimum? Okay, before I answer this question, let's make sure that we do the points for part C. So for part C, it was actually just 1 point. Okay. And so then on part D, whenever we're doing our absolute minimum, step 1 is always to take the derivative, set it equal to 0. Now, in this case, we have 3 derivatives, right? Derivatives are a rate. We have the rate in, we have the rate out, and we have the total rate. Well, to get a minimum or a maximum, we always need to use the total rate. So basically, our total rate is equal to S of t minus R of t. And we don't take the derivative and set it equal to 0 because the rate already was a derivative. So we're going to take this rate, this total rate, set that equal to 0. Okay, I will show this on the calculator. I didn't show the other stuff on the calculator because I think it was easy enough. But I will show this one on the calculator. So we're going to go to Menu, Algebra, Solve. And we're going to type in the S of t minus the R of t. And I really want us to make sure that we're very, very careful with our parentheses here, that we put both the rate in and the rate out in a parentheses. And the reason for that is when we subtract, that subtraction needs to distribute. So you always want to put your rate in minus your rate out. You want to put each one in its own parentheses. Okay, after we do our close parentheses for this, we're setting this equal to 0. So we're going to put equals 0 and then comma the variable we're solving for, in this case is t. Then outside our parentheses, we're going to put control equals from, right? We were only going from 0 to 6. So 0, control equals less than t, control equals less than 6. And this makes sure that it doesn't give us any answers that are outside of that. So we just get 5.1178. So we get 5.1178. So now we're going to make our table, right, on these absolute maximums. We made our table, so we're going to have x, and then we'll have a really time, and we're trying to find the minimum amount. So the amount, you can put y if you want to. So we're going to have 0, we're going to have 6, and then we always have our critical point, which was 5 point, in this case we said it was 5.1179, really, if we round it. So 5.1179. Now, I did this, and I did make one mistake, and a lot of students do this, and you could actually lose a point for this. And so you need to make sure you do 2 things. You want to make sure that you write equals to 0, but then you also want to make sure that you report what the answer was there. So this was t equals 5.1179. A lot of times, this right here is worth 1 point, right? The setting it equal to 0 part is worth 1 point, so you want to make sure that you write that down so you get that point. Okay. So now we need to plug these in. 0 they gave us. So 0 was given in the question. They said at time 0 we have 2,500 cubic yards. But our other 2 questions we need to figure out. So at 0 we have 2,500. And for these 2 we need to figure out. And we're just going to use our formula. And we're going to use this formula here that I circled. A of b equals a of a plus the integral of the rate in minus the integral of the rate out. And we actually already wrote this down in part B, right? Y of 0 plus the integral from 0 to 6 of s of t minus the integral from 0 to 6 of r of t. Oh, I did make one mistake in part B. In part B, you shouldn't have written y of 0. We should have actually plugged that in, right? They gave us an answer. So in part B, we should have put 2,500. So you needed that to get that full point for part B. You needed it to say 2,500, right? You need to plug it in. So we can use that formula, though, for part B and just do that to get both of those there. So what we're going to do in our calculator is we'll just type in that formula, 2,500, plus the integral from 0 to, now we can put t if we want to, or we can literally just type it in. We're doing 5.1179. So 5.1179 of, and then we'll go, control divide. This is s of t, so that was 15t over 1 plus 3t. And we have dt. And we want to make sure we go outside of our integral, way outside of our integral. And minus, now we're going to have another integral for r of t, same endpoints, 0 to, in this case, 5.1179. You could do time t and then at the very, very end put at time t. That works too. And so then this one was 2 plus 5 sine of 4 pi t over 25. And then dt. So we type all of that in, 2,500 plus the integral of the rate in minus the integral of the rate out. We get 2492.3695. And then we're going to do the same thing, but we're going to change the 5.11s to 6s. So I'm going to come up here, highlight everything, hit enter, and change my endpoint, right? Because now we have a new value we're plugging in for 6. So we're plugging in for 6. If you get something like that weird, hit control enter, and we get 2493.2767. So I know this is weird, especially when we haven't done it a lot before, but the key here, kind of to remind yourself, maybe take a note of, is that we're basically always going to have the amount at some time, say b, right? And that's what we're plugging in here. That was the 5.1 and the 6 is equal to the starting amount that they give us plus the integral of the rate in. And it's going to be from that starting point to b minus the integral from our starting point to b of the rate out. So that's all we did for both of these. We just used our calculator to make it easy on ourselves. Then they asked us for the minimum. So we'd say, I always kind of write this always the same way. I say the minimum is 2492.3695 yards cubed at t equals 5.1179 hours. And so this kind of gives me both, right? The what and then the when. So this was 1 point for getting, they gave you 1 point. Actually, this was pretty nice. They gave us 1 point for putting the equal to 0 part, and then they gave you a second point for solving it. And then the third point was for getting the answer. So even though this was really, really a tough question, you literally got 2 out of the 3 points for literally just taking the total rate and putting it equal to 0 and solving that. So definitely doable to get those points. Okay, looking at these other questions, I know you're gonna have to pick 2 out of these 3 now to do, and then the third one you'll do for extra credit. So just looking at them quickly, this one gives us a metal wire, and we have the temperature of that wire. We want to estimate t prime of 7, and then we want to write an integral for t of 7, t of x, and do a trapezoid sum. Then we want to find the integral from 0 to 8 of t prime and indicate our units. And then we want to look at, would the data be kind of consistent with this t double prime of x being greater than 0. So this one's all more of the review side. And what I want to kind of remember and point out for us is that whenever we see the word approximate, Okay, if we see approximate for basically f of x, then we're going to use a tangent line. If we see approximate for f prime of x, then we're going to do f of b minus f of a over b minus a. And if we see approximate for the integral of f of x dx, let's say from a to b, then we need to do a Riemann sum. Okay. For those table questions as well, if they ask not to approximate, but if they ask for an integral from a to b of f prime of x, that's a little bit different. That's where we do FTC. So the difference is that's f prime now. And we're assuming that the table had f of x. So we would get f of b minus f of a. So that's pretty much, review for this question. The next one is another rate question. So they say that the pollution changes at a rate of p prime of t, gallons per day, and then that there are 50 gallons of pollutant in the lake, and the lake is safe when there are 40 or less gallons. So this is not the rate in and the rate out one. This is just one single rate. They say, is the amount of pollutant increasing or decreasing at time 9? So, increasing means that the rate is positive. Decreasing means that the rate is negative. For what value will the number of gallons be at its minimum? This is very similar to part D that I just did. Right? When will it be at the minimum? We have to do exactly what we just did in part D, except we only have one rate. So just set the rate equal to 0 and do that absolute maximum, absolute minimum. Is the lake safe when the pollutant is at its minimum? So we want to go back and compare that to the 40. And they give us, part D is a little bit weird. Do your best on it, but they say that we have a tangent line. And then when would that predict that it becomes safe? So you want to set, in your tangent line, you want to think about what you want to set equal to 40. So be careful about that one. Okay, and then this last one is water is pumped into an underground tank and water leaks out. So this is another one of those two rate questions where you have a rate in and you have a rate out. So you want to be careful about that. That's very similar to the one I just did. How many gallons of water leak out? Only the leak out. How many of gallons are in the tank at time 3? So this is only the leaking out, and then this is the total. Okay, I want to be careful. When you only do the leaking out, you don't use the initial, right? We don't use the 30 initial. So you don't add on because it's only how much went out. But when we want to do the total, we need to make sure that we add on, in this case, 30 gallons is our initial. And so this is where we do that full formula. Is on part B, we would do that full formula. Part C says, write an expression for the amount at any time. And part D says, where are we at a maximum? So again, similar to what we just did. So we have those 3 AP questions. Honestly, I would really, really love for you guys to do all 3 of them and get yourself a little bit of extra credit, get yourself more practice. But if you only want to do 2 of them, that's totally fine. But pick the 2 that you're going to do.